In Unit 6, we deal with quadrilaterals. These are the four-sided polygons that we're all quite familiar with. Everything from rectangles and squares to rhombuses and kites. We've got trapezoids and parallelograms, and we're going to kind of today try to understand how to classify these different types of quadrilaterals, kind of understand the family tree of quadrilaterals. And so we're going to have just a little exploration here that I hope that we together will enjoy. Our goal today is to be able to define and classify the special types of quadrilaterals, focusing specifically on their characteristics and traits. What makes a rectangle different from a rhombus? How do we know that a quadrilateral is a square versus a kite? And so what are their character traits that we can think through, understand, apply, so that as we continue work through this unit, we can have a good understanding of those shared traits, those shared characteristics. It will help us to create equations when we're talking about the measures of angles or the lengths of sides. We're going to get to apply congruent triangles or parallel lines cut by transversal. And so there's all kinds of applications of working with this that can, reach beyond obviously the geometry classroom into art, design, architecture, woodwork, etc. So there's a lot of different applications of this outside of our classroom. But to begin with, we're just going to lay some foundation here. So here are, and by the way, as we go through this video, if I move on to the next slide and you still are copying things down, pause the video, go back, and get down your terminology so that you can have that accessible in your notes. So here are here are parallelograms and their kind of subcategories. So parallelograms in general refer to quadrilaterals that have both pairs of opposite sides parallel to one another. We had a lot of pictures of parallelograms in our previous unit when we were dealing with proving triangles congruent. We'd have a pair of parallel sides, another pair of parallel sides, and we would draw in the diagonals and say, oh, now we've got alternate interior angles congruent, etc. But at its base, a parallelogram is simply, or at its basic level, a parallelogram is simply a quadrilateral where both pairs of opposite sides are parallel. Now, every one of these special quadrilaterals are parallelograms, parallelograms, parallelograms. And so we want to make sure that we understand that foundationally parallelograms don't necessarily have these traits or these traits or these traits, but a square is a parallelogram, a rectangle is a parallelogram, a rhombus is a parallelogram, but not every parallelogram is a rhombus. Not every parallelogram is a rectangle, and not every parallelogram is a square. All right? So a rhombus is a parallelogram with four congruent sides, all right? Typically, folks will refer to this as a diamond. I'm going to draw this diamond on its sides so that we can tell that all four of those sides are congruent to each other. But if it's a rhombus, not only are those sides congruent, but they're also, the opposite sides are parallel. And so we would have to be aware of any angle relationships that would come from that, the same side interior angles being supplementary, etc. We draw on a diagonal, we're going to get two congruent triangles, just like we did with parallelograms, but these triangles are isosceles, and so we're going to learn about other features here where these angles are congruent because they're alternate interior angles, but then this angle and this angle are congruent because they are the base angles in an isosceles triangle, and so we know that all four of these angles are going to be congruent to each other, and that's exploration that we're going to have in a later section, but foundationally, we want you to understand these definitions. Rectangles, we're familiar with rectangles, obviously, for years and years. These are situations where this is a parallelogram with four right angles. Now, we know other features of rectangles, that the opposite sides are congruent, but that's actually going to be something that's true of all parallelograms, and we'll discuss those traits and features as we move forward. But the basic definition of a rectangle is that it is a parallelogram where the opposite sides are parallel, and the angles are all right angles. All right, all the interior angles are right angles. Now, a square is kind of what happens if, and this is a little awkward, and I know it's not health class, but if a rectangle and a rhombus were to make a baby, it would come out to be a square. All right, we would have four right angles and four congruent sides. So it's a rectangle because it has all right angles, and it's a parallelogram. It's a rhombus because it has all congruent sides, and it's a parallelogram. So this is kind of an inbred parallelogram there of a rectangle and a rhombus. This is what we refer to as a square. You're familiar with these concepts, but what we want to do is elevate our understanding from an elementary understanding of these ideas, vocabulary, and narrow it down to the nuts and bolts of what makes a square a square. Not necessarily all the characteristics of a square, although we will learn a lot of those in this unit. All the characteristics of a rectangle, although we will use those and learn those in this unit. We want to just foundationally understand what is a rectangle. Well, it's a parallelogram with all right angles. What is a square? It's a parallelogram with all congruent sides and all congruent angles, all right angles. All right. Next, we have these other figures. All right. We have kites. We have trapezoids, and a special breed of trapezoid referred to as an isosceles trapezoid. So a kite is a quadrilateral that has adjacent sides congruent to each other. Think of the kite that Benjamin Franklin flew. I'm sure you guys all know those stories from fourth grade or whatever when we do our little American history units in elementary days. And a kite essentially is a geometric figure. I know that there's different shapes of kites that you can fly nowadays, but a kite in a geometric sense is a quadrilateral where none of the opposite sides are congruent, none of the opposite sides are parallel, but the adjacent sides, or there are two pairs of adjacent sides that are congruent to each other. We're going to learn some interesting facts about this. Obviously, if we draw this diagonal, these triangles are not congruent to each other, but this triangle is isosceles and this triangle is isosceles. We don't bisect this angle, but if we were to draw in another diagonal, we're going to learn in a later lesson that these diagonals are actually perpendicular to each other. It's kind of a magical thing that we can understand and actually prove. The point of these in this unit this year is not to necessarily prove all these things on our own, although I will do that for you in our lessons. Trapezoids is a quadrilateral, or refers to quadrilaterals that have a pair of parallel sides. The other pair is not parallel. It's exactly one pair of parallel sides. So a parallelogram doesn't count as a trapezoid because it has a pair of parallel sides. And so it has one, it also has two pairs. No, we're not going to go ahead and say a parallelogram is a type of trapezoid. A trapezoid is a quadrilateral where only one, or exactly one pair of sides is parallel. And an isosceles trapezoid basically says that those non-parallel sides are congruent to each other. All right, so we've got the parallel sides that are not congruent, but then the non-parallel sides are congruent for an isosceles trapezoid. We're going to learn some facts and features about trapezoids as well. We're going to remind ourselves of same-side interior angles being supplementary. We're going to learn in an isosceles trapezoid that our base angles are congruent, just like in an isosceles triangle, but also that means that these angles, since they're supplements of the same angle, are also referred to as base angles, even though it looks a little awkward. These base angles are congruent and these base angles are congruent. We're going to learn about the diagonals in these polygons. We're going to create overlapping congruent triangles using side angle side, reflexive property of congruence. There's some really cool stuff that we're going to explore here, applying the awesome stuff that we learned back in Unit 4. Right? There's no pressure to remember all of those things from Unit 4, but we're going to apply them in Unit 4. I'm not going to have you do too much with proofs. Ignore the page numbers on this. This is from our former textbook. What I wanted to show you here is just kind of a way in which we can understand a family tree of our quadrilaterals. And so in general, we've got quadrilaterals with maybe no special features. So this is just all quadrilaterals have four sides. Quadrilateral. All quadrilaterals just have four sides. They've got four interior angles. The sum of the measures of those interior angles is 360 degrees. We know all that information from Unit 3. But then there are situations where we have no parallel sides, where we have one pair of parallel sides, or where we have two pairs, both pairs of parallel sides. All right? So pair of parallel sides, two pairs of parallel sides, and then this will be true for all of the items below. Now, this is referring to a kite, where we have no parallel sides, but we do have two pairs of congruent adjacent sides. Here we have a trapezoid, just a classical trapezoid. But down here we have an isosceles trapezoid, which I'll just abbreviate as isos trap. If that's okay with you, it's a little shorter to write. In our parallelograms, we've got both pairs of opposite sides are parallel. We're going to learn that the opposite sides are also congruent. We actually proved that back in section 4.4 last unit, where we drew in a diagonal, and we had an angle-side-angle congruence between these two triangles, and then by CP/CTC, the opposite sides are congruent. That's good stuff. This one here has all right angles. This one is our rectangle. This one has all congruent sides. This is 4 right angles. This is 4 congruent sides. And then this is if those two kind of inbred and made 4 right angles and 4 congruent sides. This is our square. This is our rhombus. This is our rectangle. Whoop. My end looked a little funny. All right. And so that family tree there is just something that you might benefit from referencing while you are doing work to identify what types of figures we're working with, and then trying to understand what properties are engaged with each of those types of figures. All right, so what we do a little bit in this first lesson and really expand throughout the rest of this unit is looking at our figures and making sure that we understand what figure it is that we are dealing with. So here we would look at this and classifying this quadrilateral in as many ways as possible, not specifically, but maybe as many ways as possible. You may wish to start by saying, hey, this looks like a rectangle to me, and then work backwards up that family tree. Well, if it's a rectangle, then it's a parallelogram, and it obviously is a quadrilateral. So we know it's a quadrilateral because it has 4 sides. It is also a parallelogram because it appears that both pairs of opposite sides are parallel. But at its most specific classification, we would call this a rectangle because it appears to have 4 right angles. All right, now we're judging by appearances here, which isn't always the right thing to do in geometry class, but that was the directions to judge based on appearance. So we can call this a rectangle, but it's also a parallelogram, it's also a quadrilateral. So it's all 3 of those types of polygon, D, E, F, G. This figure right here, WXYZ, we would probably want to classify this, if we're being very specific, we would call it a rhombus. And that means that it's also a parallelogram. It's obviously a quadrilateral because it has the 4 sides, the 4 angles. Parallelogram because the opposite sides appear to be parallel. And since all the sides are congruent, we know that it would be a rhombus. It has 4 congruent sides. So at its most specific, it's a rhombus. But it also will have not just the characteristics of a rhombus, but it will also have the characteristics of a parallelogram and all the characteristics that we know about quadrilaterals from Unit 3, that all the sums of the measures of the angles is 360 degrees, etc. 4 sides, 4 angles, 4 vertices, 2 diagonals, etc. We're going to skip this year. You're welcome. We would plot points and then find out what type of figure it is. We're going to skip that this year. You're welcome for that, just because I know that we just don't have that kind of time this year with our remote instruction. Using a kite. Here is example 3A. Go ahead and draw that picture to the best of your ability. Keep that in your notes because it's important to reference these things. This is a kite, and so we're going to understand that these sides are congruent and these sides are congruent. I probably should have had those labeled in the drawing, but we're going to use that information to create equations and then solve those equations. Now, this is going to be a little bit of Algebra 1, Chapter 7. It's going to be a little bit of a challenge to create and solve these equations. These 2 sides of the kite are congruent, so that means that I have 2y plus 5 is equal to x plus 6. And I also have this other equation that 4y plus 2 is equal to 3x minus 5. So here's what's interesting about this situation. I have 2 equations and I have 2 variables, but I don't have one equation with one variable and one equation with the other. Instead, I've got x's and y's, and I've got x's and y's. So what we have to do is kind of think back to our Algebra 1 skills from Unit 7 last year, where your teacher showed you how to solve a system of equations by graphing, or by substitution, or by elimination if we have these equations set in standard form. I think that the best approach to this type of exercise is to use substitution. Since we have 1x here, I can subtract 6 from both sides and find out that x is equal to 2y minus 1. All right, I can subtract 6 from both sides and find out that x equals 2y minus 1. But then I can substitute that expression in place of the x in the other equation, all right? So this is a little bit of math witchcraft, and I know that that can be confusing to us if we struggled with that in Algebra 1 last year, so that's why we're practicing it here in geometry class. So when you go to Algebra 2 next year, you are feeling comfortable and competent with that Algebra 1 skill. So we are going to take that 2y minus 1 and we're going to put it in place of the x in the other equation because this x has the same value as that x. But if this x is equal to 2y minus 1, because I made an equation, I subtracted 6 from both sides, then that means I can take that value, even though it's an expression, I can put it in here. And now I'm going to do this work to make sure that I can solve this chapter 2 of Algebra 1 equation and find out what y equals. And what that does for me is it is going to give me the y value so that I can use that information to find out what x actually equals. Again, pause the video if I'm going too fast with the Algebra 1 there. But once I know what y is, I can substitute that back into this equation over here and say that x equals 2y minus 1. We know that x equals 2y minus 1. So I can again do that algebra substitution evaluation to find out what x equals. You're free to check that math and let me know if I have an error in the comments. Give me a like and a subscribe or whatever. All right. We can do the same thing with a rhombus, and this is what I want for you to be comfortable with. We can create equations very similar, or very similarly. We know that they're all congruent to each other, so I could set these equal to each other, or these equal to each other, or those equal to each other. I think it makes sense if we do a simple equation with a's and a simple equation with the b's, just saying that the opposite sides are congruent. Now, obviously, they're all congruent to each other, but we can create an equation that's a lot easier to work with if we are using the same variable. We don't have to create a whole system of equations like we did on the last exercise, all right? And so finding out that a equals 2 and b equals 4 is, again, not that huge of a challenge for us to solve those equations. But again, in geometry class, we work very hard to make sure that we can create these equations. If this is a rhombus, then all of these segments, all these sides are equal to each other. All right, so just consider that while you are trying to create equations. We're going to apply those properties of what a rhombus is. And so we could solve this differently, saying that these are equal to each other, these are equal to each other, find out what A is, or find out what B is in terms of A, and then substitute that into the other equation. But this is obviously much, much easier. Okay, that is the end of the lesson. The goal was that you would be able to define and classify special types of quadrilaterals. Obviously, we used those definitions, those understandings, those characteristics, those key foundational characteristics of certain figures to create equations, to solve equations, finding the lengths of sides or the measures of angles. We will be applying that throughout this unit. Please let me know if you have any questions in class next time.